Hey everyone, and welcome to the first episode in my brand new series. This is a Roblox Advanced Scripting series. Now, I've asked you guys for video suggestions for this series, and I've got a lot to get through in this series, so it's going to be a good one. And we're kicking it off with ModuleScripts. Now, this series isn't for beginner Roblox scripters. If you are new to Roblox scripting and game development, I recommend you watch my 2020 beginner Roblox scripting tutorial series. I did start it at the end of last year, although it does still work in 2020 and in years to come as well, it will still work. So I recommend you go and check those out. There are currently 23 videos, although for this topic, ModuleScripts, the key things that you need to know, so the key videos that you should watch, are going to be functions, which is on the 6th episode of that series, function parameters and arguments, which is episode 7, and also returning, which is episode number 8. So I'd recommend you check those out already if you haven't, although we will kind of touch on them in this video. So if you've got a basic knowledge of scripting, this should be good for you. So module scripts are very, very useful in coding, and a lot of people don't understand them and think they're really complicated, and I did as well when I first started using them, but now I actually realize how useful they can be, and they're really, really useful for organizing your code, and also as part of something called the DRY principle. So DRY, don't repeat yourself. And the don't repeat yourself principle is because sometimes you're writing code and you need to use that code over and over again. So instead of writing it loads of times in your script, you can use a function, and that function you can call it at different times. Module scripts are basically an extension of that, in that you can write functions in a module and you can call them from other scripts. So I could have one function which does something, and I might want to call it from different scripts. So instead of having to declare that function in every single script, I could declare it once in my module script, and then I wouldn't need to write it anywhere else because I could just call it from any script. But because it's in the module script, we can access it from there. So we only need to write a function once, and we can call it from multiple scripts. Now, also, it's a good way to organize your code, because you could have your most important functions in your module, and then you could have like a game logic, which is what I covered in my Piggy series. So I have all of my important functions in my module, and then I can call them from my script. So it reduces the size of my loop script, like my game round. So if I just had a function for the intermission, choosing the player to be the murderer, teleporting players in this module, instead of having to make this main script where I'm going to be calling all these functions really long, it'd be short, and you'd be able to see step by step the program in a more organized way, because you're not having to have lots of code in there. Anyway, so how do you use module scripts? Well, a module script works very, very simply, in that in the module script, when you first create one, you'll see that you've got this table variable. So this is a variable, it's called module, you can call it whatever you like, it doesn't matter. But what's important is that the value of this variable is a table. And at the bottom of the script, it's being returned. So we're saying return module. So what does that mean? Well, we're going to be accessing this module script from different scripts. So we need to sort of download the contents of the module script into the script where we're going to call these functions from. Because we're not calling the functions from inside the module script, we're going to be calling them from a different script. So we need to somehow access all of the functions and things inside of the module script. So to do that, we need to require it. So very, very simple. You say require, and then in these brackets, we need to tell the script where the module is. We need to give a path to the module. Now, it's in server-script service, so you could either say game.server-script-service.module-script, or you could just say script.parent.module-script, okay? One of the most common mistakes with module scripts is people, instead of saying require, they just write the path to the module script, and you can't do this. I'll explain why later on. So because we want to have a reference to this, we want to store it as a variable. So local, and you can call it whatever you want. I'm just going to call it my module, and this variable here, it doesn't have to have the same name as your module variable in the module script. That doesn't matter. All you need to do though is call the require function. It's a built-in function to Roblox. Tell the script where your module script is, and now you will have access to the functions inside that module script. You'll be able to run them from this script here. So what we've done, when we've called this require function, the script has looked up this module script and it's returning everything inside this table back to our script as this variable. So this variable, my module, is now going to be a reference to this module variable in the module script, which has been returned back to the script. So whenever you say require, the script's basically looking up the module script and it's going to send back whatever's in this table. And so you might have guessed, inside this table, we're going to have functions, because we can store functions inside a table, just like we can store any other type of data, be it a string, a number, a boolean, or an object. It doesn't matter. You can have functions as well stored in a table. So we're going to have our functions stored in the table. Let's just imagine that these are functions that will run code. We will write these functions in the module script, but we'll put them inside the table. And then when we return this table back to wherever it's been required from, so in this case the script, what's going to happen is my module, the variable, is actually going to hold that table of functions. So we can now call these functions from the main script, which is outside of the module. So how do we put the functions inside the table? Well, it's very simple. Firstly, what you want to do is say module, or the name of your variable, the name of the table. And then we have to do a dot, and we write the name of our function. So, it's kind of like a variable, because say I wanted to call it my func, okay? That's what I would write if I wanted to call the function, okay? So module.myfunc equals, we want it to be equal to a function, okay? And now you can see it's added the end. We could write some code inside of here, okay? So when we call this function, it's going to print, hey there, this is the myfunc function. Now, you may be wondering, hold on, it's not in the table because it's not within these brackets. But it actually is, because what we've basically done is we've created a new object by using this variable. We've created a new index in the table called myfunc, and we've set it to be equal to a function. So now inside the table, we've added this function. So when we return that table back to wherever it's been required from, if we wanted to execute this function, we would firstly need to get the table, which is going to be my module. And if we say dot, you can see myfunc has appeared in the IntelliSense. So it is smart because the script knows that we've required and we've kind of downloaded, so to speak, the contents of the module, and it sees that there's a function in that module table called myfunc. So if you just press enter or write out myfunc, you can see it adds the brackets, so it's called the function. So to call a function inside the module, you firstly have to have the variable of the required module script, so you've got access to that table, and obviously that table has the different functions inside of it. Because we gave it a name, myfunc, and we set it equal to be this function here, what's happening is we can then call it from outside the module script. So if you now run the game, it prints out, hey there, this is the myfunc function. Now, something I must add is that when you are using a module script, the code isn't actually running on the module script. It's running in your script. Now, I'm going to show you an example of this. Now, you probably know that we have client code and server code in Roblox, in that code can either run on a player's computer in a local script, in a service such as the player GUI or backpack, or even in their player object, or it can run on the server in a place such as the server script service or server storage. So module scripts, they can either run well, they run wherever they're being required from. So if you require a module script, which is in replicated storage, which is a service which can be seen and accessed by the server and the client, if you were to require that in the client in a local script, it would be running on your computer. But if you were to require the same module from the server, that code would be running on the server. Okay, so the whole require thing is basically running the code in the module script within that script. So if it's a server script, it's going to be running on the server. If it's a client script, it's in a local script in somewhere like Player GUI, it's going to be running on the client. And I'm going to show this to you. So if we call it from the server script service, but we also just take this code and we put it in a local script in Starter GUI, watch what happens when I play the game. So, oh, whoops, my bad. We transferred it to replicated storage. One moment. Okay, brilliant. So if we just ignore these plugin errors, we have two prints, and you can see the green one, when it's green, it means that it's run on the server. When it's blue, it means it's run on the client. So what's happened is the green one, if we click it, it's taken us to it's green because it's run on the server. So it's run in the script in server script service. But in the blue one, it's been run in the client because it's blue. So it's been run in the local script. So it's not actually running in the replicated storage in this module script. It's running wherever you require it to. So it's, I guess, an analogy which I don't think it's the best, but it's a good way to try and explain it. Is if I was to put a tutorial or some instructions on the internet of how to bake a cake, right? And I just published it on my website, but then loads of people around the world in different countries were downloading this recipe or these instructions and actually executing them in their own kitchens, in their own houses, right? They're using my instructions, but they're not running them in my kitchen. They're doing it in their own kitchens, in their own homes. But it's just that I've supplied the instructions, the recipe, and you can think of the recipe as being the module script, and the individual scripts that are requiring and calling the module script as being the people all around the world downloading the recipes and actually following them and using them in their own kitchens. So it's not that it's just running for me. It's not running in the module script. It's people are taking the recipe and using it and following it in their own kitchens across the world. But that one recipe or instruction was posted online so everybody can access it. So it can be accessed from multiple places around the world. So just kind of in that sense, the module script is a good way for you to put code which you're going to execute. You know that you're going to run it a lot over and over again, especially in different scripts. So instead of repeating yourself and writing that same function over and over again in loads of different scripts, you can write it once in your module and you can call it from lots of different places. So let me give you a practical example of this. Okay, so an example of this is if you have a round-based game, it's likely that you're going to want to be using countdowns a lot. So you'd need to be using for loops. So you might have a countdown for the intermission, a countdown until the next player gets chosen, a countdown for players to hide if you've got a hide and seek game, a countdown for then the round that's in progress before it ends, all sorts of countdowns. So you can consolidate this, and you might need to count down in different scripts as well. So in my module, I've created a function called countdown, and I've got 4 parameters. It's going to be the number to count down from, the number to stop at, the incrementer, so the number of seconds of delay each time, and the prefix as well to print before the, because it will print out the countdown, so the prefix could be like intermission and then game in progress, so it will print before the time left. So now that I've created this function to count down, I no longer have to do lots of for loops in my main script where I'm calling it from. All I need to do is just call this function, and it's really neat just one line, I can pass all the information I need to my function. So I want to count down from 30 to 0, going down by 1 each time, waiting 1 second. And then the prefix is going to say intermission before the I number. So you can see I just call the function. Once it's completed, it will move on to the next thing, and then it will count down from 100. So I'm going to actually change this to 10 seconds, just so that you won't have to wait as long. But if we open up the output, this was from when I just tested it, you can see it counts down from 10, 9, 8, 7, 6, 5, 4, and this is running in the server script as well. It's just been required from the module, obviously, and then it starts counting down from 100. So you can see one for loop in one function, and yet we're able to use it over and over again, not just for the intermission countdown, but also for the round in progress. And you can see how it saved these lines of code, and it's more efficient because we've only had to write out the for loop once, but we're using it over and over again in that function. So very, very useful on ModuleScripts. I'm now going to show you another way of putting functions in this table, which might make it a little bit easier for you to understand. So you don't have to do this way. You can do the other method I just showed you of saying module dot and then do the name of the function equals function. So if we just expand this table a little bit so we can work with it, very simple. All we need to do is write the name of our function. So this could be countdown again, and we just say equals function like this. Okay, so we've created a object or an index in the table called countdown so that we can reference this function, and we've made it equal to this function here. If I was to do print executed, and we were to just call the countdown function and run it again, it would say executed. So same sort of thing really, you know, whichever way you do it, the function is still going to be put inside of the table, still going to have the same name, so you can call it. So that's just another way of putting functions in your module table. And the reason people return tables, the reason the module variable is a table is because it's likely you're going to want to return multiple functions to the script. If you didn't have a table, you would only be able to return one value, so one function, whereas you might have multiple functions in your module script that you want to execute. So you can have multiple functions, so I could call another one, test equals function, but you can see there's a red line underneath it, and that's because in a table, you have to separate each object with a comma or a semicolon like this. So when you do that, the red line will go away, and you now have two functions. So you could call the countdown one, or you could call the test one as well. Doesn't matter. So you can see they both worked. So when you're adding a new function to your table like this, obviously you need to put the comma in. But if you're just creating a new function in the previous way that I showed you, like this, okay, if you wanted to create another one afterwards, you wouldn't have to add a comma, because it's essentially doing it for you. When you're saying module.test, module.countdown, it's inserting it into the table for you. You know, we can't see it right now because the table is blank to begin with, but then we insert into the table this function, and then we also insert another one. So it adds it for you. And the name just gives it a really simple way for us to look up and locate each function when we want to call it as well from the script. So just some key takeaways then, and to conclude, we'll do some frequently asked questions that I've found on the internet, so that we can try and answer some of your questions. So Regenerate on the dev forum says, I am trying to become accustomed to using module scripts. I already know that I have to call require on any module script in order to run it. My question is, how do you use specific functions you define in a module script in a script or a local script? So that's what we've gone over. Obviously, in the module script, we're returning this big table, and that table is going to contain all of our functions, which we've just added here. And because we've given each function sort of a name, kind of like a variable, the name for its index in the table, to execute the function, because it's tied to this name, we just need to get the module, and we need to require it in our script, and that basically gives us a copy of the module script that we now have access to in our script, so that we can see the because when we use require, it gives us the returned value from the module script. So because we returned the module table, which contains all these functions, my module, the variable, is now going to be equal to this module table, and that module table is going to contain all of these functions which we can call. So now we have access to that table in our script. We can call all of those functions as we do here, and when we do call those functions, they're being executed within this script. So if you're requiring or getting the module in a local script, which is in player GUI or somewhere else that's located on the client, it's going to run on your computer. It's going to run in a client environment. But if you run it on the server, it's going to run in a server environment, in a server script. So, for example, if you're requiring a module on the client, which is trying to access something in server storage, it's not going to work because it's running on the client. Whereas if you do it in the server, it's going to work because the server has access to server storage, whereas the client does not. So, very simple. We just put all of our functions in this table, return the table, and then whenever we require it, it's essentially just running the module script and returning whatever we returned. So in this case, the module table, back to our variable here in the script. So we now have access to all those functions. Okay? And module scripts, they don't have to be used just for functions. So for example, I've just changed the module variable in the module script to be 350. And so when I say return module, obviously you can't say my_module.countdown or .test2 or call any functions anymore because we've got rid of them. We just got 350. So we're returning the number 350 back whenever we require it. So my module is now going to be equal to 350, like this. So this is useful if you're having a module for an inventory in your game. So if you've got information about all the different items that you sell in your game, say you had like a shop or a pet shop, you could have a module script which in the table you could have subtables. So for example, if we just have a pet called Dragon, and that has a subtable, and it has information about its cost, or its, I don't know, its age. Maybe the dragon has its own age in years, or its health. Maybe it has 150 HP. So you can have all of your different pets or items in your game. Don't forget the comma or semicolon, like this. Okay, I'll just call this one bird. Okay, change its cost, something else. Okay, but then when you return this table, it doesn't have to be called module either. You could call it item table or pets. Wait, let's just call this module script pet module. Call it pet module. Okay, so if I wanted to, for example, let's imagine that this module script is running in a shop GUI, or I know it's not in the client, but let's imagine that we need to get all the information about all the different pets that we can buy in the game so we can show them to a user. Well, because we've required the module and it's returning this table of pets, we could loop through everything. We could loop through this table of pets because it's now my module, because it got returned from the module script back to the server script. So we could say for I, the in pairs. I don't think I've explained this to you yet, by the way, but when you are looping through a table like this, like a dictionary, where you've got names of tables like the dragon, so this is going to be a key, and this is going to be the value. So inside this big table, we've got keys, and each key has its own value. So you can look up the dragon by using the key name dragon, and it will give you the value of that key. So when you loop through a table like this, the I usually call it key name, and that's going to not, instead of being the number, so the first index, second index, it's going to be the name of this table or this key. So in this case, it'll be dragon, and the key value will be this table. So if we wanted to get the cost, we would just say key value, because that's the table, and inside of it, there's a key inside of that table called cost. Okay, so we could say print the key name to begin with, then we could print out the cost, then we could print out the age, then we could print out, what else was it? The health. Okay, and if we print this out, you can see it's printed out dragon, then 350 because that's the cost, and then the age is 5 and the health is 150, and then the bird 564 to 100. So what's happened is the script this is running the script, by the way, so it's looked up, it's required the pet module. The pet module has sent back the pets table, which is full of all this information about the different pets in the game. Then we've looped through every key or subtable in that table and printed out the name of the pet, the cost, the age, the health, etc. So you can see where this is going. So if this was running in a GUI, you could create a new button or image label for each pet, and you could hook up a load of events to it, like a mouse button one and click event, mouse button, I don't know, whatever, so that when you click that frame, you'd be able to buy that pet. So very, very simple, but you can see where I'm going with this whole module stuff, because not only can you hold functions, but you can hold information about things in your game, because you might want to access the information about the pets in different scripts. So you might have a script in the client, which is getting all of the names of the pets and all the information about all the pets you can buy to show to someone who's in the shop. But you could also have a server script that is doing it needs to check the cost or the health or the age of a certain pet, so it can just look up in the pet module, and because it's in replicated storage, it's visible to both the client and the server. But the module scripts, they can be anywhere, and they're useful for lots of different things. But you have to return something from a module script. You always have to return something, so that when you require, you can send something back. So again, it doesn't have to be a function, it doesn't have to be a table, it could be a number, it could be a boolean, it could be an object if you wanted. I'm not really sure why you'd want to do that though. So the main use cases for a module script is for information about things like inventories or tables or things that are in a shop. But also another main use is for functions, for holding functions, so that you can execute these functions in different scripts, okay, and so you don't repeat yourself. Another good reason to use module scripts for functions is that if you need to update your function, instead of having the same function in loads of scripts, you'd have to go through and update every single script. You can just update it once in the module script, and because you're calling the function from the module script in different scripts, it's just going to update itself, because you updated it once in the module script, so it's going to take effect everywhere. So that's a very, very useful reason to use module scripts. But you shouldn't be using them all the time, so don't go thinking that every single function that you write you need to do in a module script. If you're only going to use it once in one script, then don't bother with a module script. Now, I write lots of functions that are just going to be used in one script to do something, so don't just think that you have to go and use module scripts all the time for everything, because you can overcomplicate things, and they are unnecessary for some things. Now, a lot of people have been asking me about something else called G and what that is compared to module scripts. Now, G is basically a global variable which can be accessed from different scripts. So in this script 1, I'm saying I think it's an underscore G dot awesome variable equals 50, and that's created a global variable which I can access from other scripts. So in script 2, if I wanted to print out the value of g.awesome variable, which if you notice I haven't created in script 2, I've actually created it in script 1, but if I ran it, it would after 2 seconds print out 50, because that global variable has now been initialized by script 1. It was created in the script 1, and so I can get its value. But there are a lot of downsides to this, and it's kind of useless nowadays because we have module scripts. I just wanted to touch on it because a lot of people have been asking about it. There are some flaws to it, especially if you are trying to get the global variable, the G variable, before it's been created. So sometimes you might be trying to access it, but it hasn't been created by the other script yet, and it gets really messy as well. You can't create one on the server and then try and fetch it from the client. So if I created it in script 1 on the server, then try to access it from a client script, it wouldn't work. It would just return nil, because you can only have global variables which are created on the server. You can only view them from the server in other server scripts, or created on the client, you can only view them in other client scripts. So it's not useful, and please don't use it. Just use module scripts instead, because module scripts are much better, because You can create a module script and access it from the server and the client if it's in replicated storage. And also module scripts are a lot faster as well, because G is a old and slow way of having global variables. I'm going to quote "Fear me, I am lag" from the developer forum, who says module scripts are a much better option than using G, and it's definitely what Roblox is trying to lean developers towards. In my experience, G is less efficient, causes lag, and is less favourable. And I would absolutely echo that. Definitely use module scripts wherever you can. It's the new practice. G has been around for ages before module scripts, so use module scripts. Don't use G. It's a bad practice. Module scripts are the way. You know, unlike G variables, you don't have to wait for a value or variable to be created with a module script, because you know that it's there as soon as you've required it. So you could, you know, go local my pet module equals game require. In fact, I need to touch on that. So I said earlier in the video, a lot of people, is a common mistake not to use require, and I'll show you why. So if I was just to say game.replicatorstorage.pet module, and then I wanted to print out the pet module, so I want to print out the, okay, I changed the pets thing, by the way, to show you something. I've removed the pets, but I've put an index in there called awesome variable. So if I wanted to get the value of awesome variable, I would just say pet module.awesome variable. Okay, because it's in that table that got returned to me. Now, because I haven't used require, this is just a normal variable for an object. So the script thinks that the pet module, well, the pet module is an object, right? It's the object of the module script. So the script is trying to look for an object inside the pet module. So as if there was something inside of it called awesome variable, right? But there's not an object inside of it called an awesome variable, so it's going to cause an error. You can see it says awesome variable is not a valid member of module script. And this is because it's looking for an actual object, an actual thing, like a part or something, inside of the pet module, not the actual table in the script. So when we say require, it's getting that return table. And so pet module is going to be a table object, or whatever we return. So if we don't return a table, we just return 500, it would be a number. So if it's a table and it contains the awesome variable, it's going to work, because it's going to look up the awesome variable inside the table, and it's going to print out its value, which is going to be 500. Just like that. Anyway, I hope you found that video useful on module scripts. If you did, please leave a like, share it with anybody you know who'd benefit from this, and don't forget to subscribe to my channel for more Roblox scripting videos. Again, I have a 23-part and counting beginner series, which is useful as well if you need to catch up on some things that you have forgotten, or if there's just some things that you've missed and need to learn. I recommend you go back and check those out. Anyway, I hope you enjoyed this video. Thanks for watching, and I'll see you in the next one. Cheers, bye.